This was June 1999. Now this is a very, if you see this question, you will be so confused because he gives you so much stuff. You don't know where to start. But it says calculate the coal consumption per kilogram of hour for a boiler with the following operating conditions. So it's a very simple question to do, but it's so much stuff, you don't know where you are. The feed water inlet temperature is 150. The final steam temperature is 400. So that gives you the H2 minus the H1. That's just what you're getting out. What you're putting in, you need to look at the calorific value and you need to look at the amount of coal that you're burning. So he says the steam pressure at superheated outlet is 4 MPa absolute, steam drum operating pressure 4.5 MPa absolute, calorific of the fuel is 27.5. That's air dry. That means it's totally dry. There's no moisture in it. Moisture content of the fuel in the bunker is 3%. Moisture content of the fuel as fired is 10%. And overall operating efficiency is 75%. Feed water flow is 108 tons per hour and the steam delivery flow rate is 100 tons per hour. Then it says the following information is extracted from the steam tables. Absolute pressure, 101, 481, 4001 and 4005,1, and then it gives you temperature, HF, HG. Now you're not sure what to use. Then it says additional information required must be interpolated. So where do I start? Now, obviously, I will need to calculate the boiler efficiency, because from the boiler efficiency, I can work backwards and then get the value that I want. So I said H2 is the enthalpy of the steam superheated at 400 degrees Celsius and 4 MPa. Sorry. Then I also say the tables given the exam only gives saturated steam enthalpies, not superheated, because they are all in. It doesn't give superheated, just totally saturated values. These are just for saturated, not for superheated. So I need to understand what is the degree of superheat. So you can then do this calculation to say that from the steam table, superheated H soup at 400 degrees Celsius is 3214,7. I just wrote this down out of interest. You would have not known this, but I want you to understand where I get, if I do my calculation, it's very close to what we have there. So I've read this off from steam tables. So I said HG superheat is Hg at 4 MPa, so that'll be the total heat of the, that'll be the total enthalpy of the saturated steam value at 4 MPa plus the degree of superheat. So HCP superheat is 2801, that's that value there, and you get that from your table. If you go back to that table, at 4 MPa. I'll just go back there. So I'm interested in that value there, that one, 2801,5, because I'm working at 4 MPa. Then the 2157, that's another value, a CP of the superheated steam, which he didn't give you, and you need to know that, times the 400 minus the 250,42. The 250,42 is the saturated temperature at 4 MPa. If I go back there, that is there. At 4 MPa, that's the heat value, and that's the saturated temperature, 250. But it's actually at 400 degrees Celsius. That's a final, that's a superheated value. So then the H superheat I can calculate by doing this calculation. And you need to understand this. You need to write this down on your list of formulas. Otherwise, you will not be able to do this. And that gives you 3124,14 kilojoules per kilogram. And that's very close to that value there, which I read off a steam table just to make sure that we're on the right track. Then, sorry. Then H1, which is the inlet temperature is 150 degrees Celsius. The feed water inlet temperature is 150. Now, remember we used to work with 50 and 30 in it, but that sounds more correctly. Times 4.187, that gives you 628.1 kilojoules per kilogram. The efficiency of the boiler is then the mass of the water times H2 minus H1. I calculated that one. This one I calculated up there. The mass of the fuel I want to know. The efficiency of the boiler, he told me, is 75%. And the calorific value is 27.5 times 10 to the 3 kilojoules per kilogram. And the mass of fuel is then 12540.12 kilograms per hour. But the fuel burned has 10% moisture. So the mass of fuel will be mass of fuel times 1.1, because you will need more fuel to burn that 10% of moisture that's on the, you'll burn more fuel because you've got that 10% moisture on the fuel already to be able to get these enthalpies that I'm talking about, yeah. And that's it. Any questions on this one? You need, before you ask me a question, it's very important, yeah, to understand this principle, the degree of superheat, and where do I get this from? And why do I use from the steam tables in what is given me? Why don't I use 4501? I use 4001, I use that is my saturated temperature, although the boiler is operating at 400 degrees. So that means 400 minus 250 is the degree of superheat. And the enthalpy of the steam at that value is this, plus the extra from the superheat. Any questions on this one?
Willem, I just want to ask on the thermal efficiency, when you go to that formula, they give you two different mass flow rates. They give you one for steam and then one for water.
Yes.
And I've seen, I think you've actually only used the one for steam. Are you not supposed to split those two up? So you say 100 tons per hour times your enthalpy of steam minus your 108 tons per hour multiplied by your enthalpy of water.
Yeah, that's a good question. Sorry, just say again, you will then?
Okay, to your thermal efficiency, efficiency to that formula. So you've above the line you've used 100,000 kilograms per hour, and you use that for both enthalpies. But
yes,
in your question, they say, all right, 100,000 is only for the steam, but you've got 108 tons per hour for your water. So what I'm asking is, shouldn't you say 100 tons per hour times H2 minus 108 tons per hour times H1?
Look, I think that's probably more correct, but between the feed water flow rate and the steam, there's 8 tons per hour that got missing. So I'm not sure if that's leaks or stuff like that. But at the end, I only used the 100 because it's the difference in enthalpy, and at the end, the steam, the amount of steam that I'm actually going to send to the turbine is the one that matters. But I think you're 100% correct, and it's more correct to do it like that. But if I'm not sure if in the government ticket it goes as detailed as that, if I can say that.
Yeah,
But
I don't know.
I'll also check that for you. I'll do that.
All right, thank you. I appreciate it.
Yes.
Thank you.
Yes. Does everybody understand what the question asks? So I've got two things which I'll check for you by Wednesday. Yeah. Okay. Then you.
Sorry, Willem,
Yes.
sorry.
Yes.
I have a question also.
Yes.
So they said the moisture content of fuel as fired is 10%, and the line above that also says moisture content of fuel in bunker is 3%. So would you
Yes.
not say it's actually 13% of moisture in the fuel?
Yeah. No. I'll tell you why. Because the moisture content of the fuel in the bunker, that means just above the bunker feeds the mill, and the mill grinds it and then sends it to the boiler, makes PF of it, pulverized fuel, and sends it to the boiler. The 10% is what I'm firing. So I'm talking about the heat as fired in the fuel. So I'll just use the 10% as it is. I'm not sure if the FD fan, no, sorry, yeah, the FD fan, the one
yes,
that's in the
that
primary air
supplies air.
fan,
Yes.
if that actually got moisture in it and it goes from 3% to 10% in. I'm talking about in reality. In reality,
Correct.
I'm putting more moisture into it. Yeah. So the fuel itself had 3%, but by the time I'm actually burning it, as it goes into the burner, there's another 7% that is added, and that can only come from the air that I'm mixing with it. Yes, which comes from the PA fan and the FD fan. Yes. Yeah.
Okay. So there was one question I've seen, not the ones that you've given us, where it says unburnt coal. So that you
Yes.
minus it from the 100%, am I right?
Yes. Yes.
And thus, so if there's moisture in the coal, you're adding it to your 100%.
Yes. Yeah. Because I need to burn more to get the same heat value out.
Okay, I get
Yeah.
that. Thank you.
Yeah. Sure. Anybody else? Okay. Okay, that's all I have for you guys today. I will, if there's any other questions that you might think about on what we've done now, please ask me on Wednesday. And if there's any other questions, I know your time is limited, but if there's any other questions, I tried to do the 4 types of questions. The only one I didn't do is stoichiometry, which you've got the amount of carbon and hydrogen and all that. But if you want one like that, we can do one. But okay, Mariana, thank you. That's my portion.
Thank you, Willem. Okay, so I'm going to close it then off there.